So in this tutorial, we are going to look at what are the various types of loops in Python and when to use them. These are the content that we are going to go over in this tutorial. We are going to just have a basic intuition about what are loops and when to use them. Then we are going to use and look at a few of the common examples of looping techniques in Python, which includes for loop, while loop, and list comprehensions. Within for loop, we will also see the basics of for loop, unpacking, zip, map, and enumerate functions. Then we will also see the various control statements that you can use within a loop. That could be break, continue, pass, and else clause. Then we will also cover the nested loops with some sample use cases, and then we will finally conclude the session. So let us take a step back and understand why we started programming in the first place. It would have been to avoid some manual tasks which were something that we were doing on a repeated fashion, and we want to avoid such things using programming. So at the very heart of programming are logic statements. Anything that you want to build cannot be built without logic statements. So suppose you want to find out whether a particular number is even or odd, then you will have to write a if clause to check whether the number is divisible by 2 or not, right? Now, once we program such kind of things, but you have to check for a large number of entities. Suppose you want to check for 1,000 numbers whether they are even number or odd numbers. So you could not go ahead and write 1,000 if clause to check whether each of them are is an even number or odd number. In such cases where a particular operation is done over multiple entities and that cannot be done manually or cannot be written in a manual fashion, in those scenarios we use loops. Loops are essentially execution of same statements over and over again over multiple entities. So with that fair intuition of looping in your mind, let us look at few of the syntactical things that you can use in Python, various looping techniques, and what are the various clauses that you can use along with it. As usual, we will share this notebook in a GitHub repository and attach the link in the description below. So let us start with a while loop. So in while loop, the syntax starts with a while, and then you need to write a condition. The condition could be anything like a less than b, and then you have to write a statement which it will execute upon whether the condition is true or not. So until the condition that you have put over here is true, it will execute the following statements. So I will just say print a, and I will increment a by 1. Okay, mind you, you have to increment or decrement your conditional statements or add a logic which will eventually make this loop terminate. Otherwise, it will go on an infinite loop. Okay, so for now, I will just add a is equal to 1 and perhaps b is equal to 5, and it will print all the values from 1 till 4 as long as a is less than b. Okay, so let's just quickly execute that and see. Okay, here we have printed all the values from 1 till 4, and we are incrementing a by 1, so this statement is eventually going to become a false statement, and that will, once the statements become false, all the codes inside it are not going to execute. Okay, then it will flow, the controller will flow till here. Okay, so let us now take an example or just change the use case in such a scenario that you want to break your loop once a particular condition or statement comes true. Okay, so say that you have a number a and you want to print till number b, but you have one condition that you have to print till 50 only. You cannot print any further, but you do not have the control over b. So the b may be a user input or anything uh, of which you do not have the control. It could be 1000, it could be 20, it could be 50 itself. Okay, but the condition is that you would not want to print anything beyond 50, but you want to print till 50 only. Okay, or just say 5. So upon a successful condition statement, I want to break this loop. So for that particular thing, you can just write if a is equal to say 5 or something. I want to break this loop. So as soon as my a hits 5, I do not want to print anything further, and I do not want to reach till b and break the loop. Okay, so let us just quickly see this how it works.
Okay, so here you see that though we have b is equal to 1000, so ideally our loop should run till 1000. But since we have added a break condition that as soon as my a hits 5, break my loop. Okay, now if I just make b a little bit less of a number, say 3, it will execute as it is, as intended, because a never hits 5, so the loop is never broken. Okay, now along with this, there comes a new syntax or a new clause, that is else clause. So in else clause, okay, before that, let us just revamp break. So in break, the control flow of this particular loop will come out of the nearest loop as soon as it hits a break statement. So the nearest loop right now here is while. Uh, if you have nested loops, one underneath the other, it will break out of the nearest loop which it is written. Okay. So now comes the new statement of else. In else, what happens if your loop is successfully terminated in a normal fashion without hitting any break statements? Then it will come to the else part. Okay. So I will just print, say, I am in else. Okay. So since right now our A and B are 1 and 3, so our break statement will never get hit. Okay. So the control will flow to else. Let us just quickly run that and test that. Okay. So right now, since we have successfully exited this loop in a normal fashion, our else statement got executed. However, if I just make B a little higher, say 10, and I will hit the break statement at this point, at that point of time, my else statement won't get executed. Okay, great. So this is all about break and else statement.
Let us take another use case of skipping a particular entities while looping. Okay, so how would you skip few numbers when you are trying to print the numbers from 1 to 10? So say I want to print only the numbers which are odd, and I want to skip all the numbers which are uh, even numbers while printing. So in order to do such thing, we have a particular keyword which is called continue. So all you need to write is you need to write your condition based on which you want to skip. So I can just say if a modulus 2 is double is equal to 0, if it is even, they just want to remember, even while you're skipping, you have to keep your counter update so that it does not fall into a forever iteration. Okay, and then you just update the counter and then you press continue. So in continue, what happens is it moves the control back to the top of the nearest loop. Again, the nearest loop term has been used over here since it only moves to the nearest loop in which it is placed. So if there are multiple loops or one nested underneath the other, it will move your pointer or your control directly to the top of the execution again and start from there again. So over here what happens is it will check whether a modulus 2 is 0. If it is, then it will increment the counter of a and it will continue and it will skip all the elements that are within this loop and finally again execute the else loop upon successful execution of the entire loop. Remember this, with continuous statements your loop are normally exited, so that's why the else statement is also going to execute. Okay, let us quickly print and see this is in action. Okay, so over here we are able to see that from 1 to 10 it has printed all the odd numbers, it has printed it was in else, and finally it printed a as well because that is just something that we had added up. So remember, in break statement it is not a normal exit from the loop, that's why the else statements never get executed. However, if you have continue, it will execute as in a normal fashion. So let us look at this template and summarize what we have learned for while loops. Okay, so in while loops you need to add a counter or any particular logic which leads your loop to terminate, otherwise it will loop on forever. Then you can use a continuous statement to move out to the nearest top of the loop. Okay, and skip few things. Along with continuous statements, you need to keep in mind that you are still decrementing or incrementing the counter based on which your loop is getting executed at a iteration fashion. You can use break to break out from the loop in a non-normal fashion. In those scenarios, it will not execute the else statement. However, if you are using continuous statement, it will execute as it is and will execute the else statement at the end. Okay, great. So with that, let us move to the nested while loops. So nested while loops kind of work similar to the while loop only. So it's a while loop inside a while loop. Again, you can do all the same operations that you were able to do in while loop. So you just need to remember, for each of the loops that you are using, you need to put some logic or statements which will in turn make the entire looping statements or the logics based on which the loop is running false at some point of time. Okay, so this is just one example. I'm just looping from 1 to 5 in this entire loop, the outside while loop. And if I hit continue right now, if I hit this continue, what will happen is it will jump to this particular while loop, the head of this. However, if it hits break, it will break out from this while loop, not the outside while loop. Okay, let us quickly see this in action. So this is the printed form of it. I will just print it again. Okay, so for iteration first, my A is 15, B is 20. Till B is greater than A, I'm going to check whether B is an even or not. I will decrement B and continue. So it is printing only the odd numbers as we have discussed, and as soon as it hits 16, it will break. So as soon as my 17 is hit from this particular iteration, it is hitting break and it is going back to the top of this loop. That is, it is breaking from this loop. However, once you hit continue, it continues and goes to the nearest loop. Okay, nearest loop's top. So continue goes to the nearest loop's top, breaks out of the nearest loop in which it is placed. Okay, I hope with this break syntax and the continuous syntax is a little bit clearer to you, and it will become more clear if you practice on these things. So the next thing that we are going to learn are for loops, okay, and how to use them. And before starting with for loops, let us look at how unpacking works in Python. Okay, so in Python you can assign directly in this fashion, in which 1, 2 is treated as a tuple, and again a, b is treated as a tuple, and each of the element corresponding to the other's position are assigned to each other. So if I say 1, a, b is equal to 1, 2, then a and b takes the value of 1 and 2. Okay, so just go ahead and print this 1, 2. Similarly, if you write in this fashion, a, b within brackets, c is equal to 1, 2, 3, then again each of their position just opposing to the other tuple's position are assigned the value of each other. Okay, this is also true for in case of strings. So instead of a, b, you can unpack a string within itself and assign it to it. However, mind you, the string values cannot be more than 2 numbers. Okay, in that case, it will throw an error that there are too many values to unpack and too less variables. Okay, so the value has to be same, or it could be again xy comma same thing could be there, and it will unpack the value in this fashion. Similarly, if you have multiple values that you want to assign to B, and you just want to assign one value from start to A, one value from N to C, you can just do that. Otherwise, you can just take 2 values from start, assign the entire rest of it as a list to C, and same thing with A as well. However, you cannot use 2 stars or multiple assignments for 2 elements, as Python won't know exactly how many of elements do you want to pass to each of them. Okay, so if you run this will create an error. So the next thing that we are going to learn is the range function. Okay, so range essentially takes 3 arguments, but you can also pass a single argument and it will work. So if you pass a single argument, then it will create a range of elements starting from 0 till n-1, whatever the element that you have provided. Okay, and it will actually provide you a range object which you can use in for loops. Okay, so it will give you a range object that starts from 0 and ends till 10. Okay, you can also change the starting position to something, say 4, and it will give a range object which starts from 4 and goes till n minus 1, which is 9. Okay, you also can specify a step number which will show how many steps it takes after each jump. Okay, so if I say 2, it will give me a range object which goes till here. Let us just put this in list and see how what all numbers do we get. Okay, okay, so right now I'm getting all the numbers from starting from 4 till 9 at a 2-step increment. Okay, so 2's 4, 6 and 8. If I just make it say 1 right now, 1, and let me just remove this step, you will be able to see that I am generating all the numbers from 1 till 9. If I have to generate till number till 10, I have to create this at 11. Okay, then I can just specify a step and it will give me all the numbers at this particular steps increment. So 1 plus 3 is equal to 4, then 7, then 10. Okay, the same thing is written over here. Okay, now let us move to the syntax of for loop. Okay, and how it works. So in for loop takes an iterable on which it can iterate upon. This can be anything. This can be a list, tuple, dictionary, or a custom range as well. So you can provide a range 1 to 11 over here and print that. So I'm just pasting this and it is going to print all the numbers from starting from 1 till 10. I can also change this range and make it as 3. So it will provide me all the numbers in a 3-step increment. Okay, and all the things that we were able to do with while loop are also doable with for loop. You can put a continuous statement. Again, it will move the control to the top of the nearest loop. You can use a break statement. It will move the control out of this loop in an abnormal fashion. Okay, and similarly, if you exit this loop in a normal fashion, then your else statement is going to get executed. Okay, so let us just print this and see that right now it's able to exit this loop in a normal fashion. That's why it is executing this else statement. However, if I change this to say 5, then it will break out of this loop and will not print this else statement. Okay, so this is about for loop. Now over here in for loop, all the unpacking that we have just learned can also be used. Okay, so just as we saw that we can unpack multiple variables, we are able to use them over here. So instead of just a into b, I can just write a into b. It will multiply all the numbers within it and give me a result. Okay, similarly you can unpack 3 variables in for loop. You can unpack everything that we have learned in this fashion. You can unpack a, b and c from this set of variables and list comprehensions. Okay, then again this is another same example where you can pick out multiple elements and finally put them in a list and take a single element from this particular set. Okay, so it will give me a list of elements of these 2, and this is a single element, just as we see over here. Now let us see how you can make such kind of tuples from multiple lists, okay, which you can use in your loop conditions. So say you have 3 lists, each having similar number of elements, and you want to make tuple from each position's value. So I want to make a tuple of 1, 10 and 10, again 2, 20 and 20, 3, 30 and 30, and for each such tuple I want to iterate over them. Okay, so let us just see how zip can help with that. So in zip you can pass multiple lists or iterables and it will create a tuple based on the position of each list's element. Okay, so just let us print this and see what happens. Okay, so it has taken all the elements from the very 0th position of all the lists and created a tuple. Again it will take all the elements from the first position of the lists and create a tuple, and so on. Okay, so this is kind of crucial, and it can be handy while you're creating your loops in using for loop. Okay. Similar thing, you can just utilize this and multiply all the values from the list and print out them. Okay, great. So this is one handy tool that you can use while you're coding using for loop. So the next thing that we're going to look at is, many a times we see that we need a counter to count the number of loops or iteration that has gone by. Traditionally, if you are familiar with C language or any Java or any particular other language, we have seen that we can use a counter variable which can be initialized to 0, and every time we iterate before exiting the loop, we increment the counter by 1 or any step value, so that we have a count of the number that is getting printed. Okay, so I want to iterate from all the numbers from 1 till 19 with a 3-step increment, and I want to keep a count of my iteration. Okay, so I will just run this. At the 0th iteration I have 1, first iteration I have 4, second iteration 7, and so on till 66th iteration I have my 19th value. However, this is a little bit syntactically different to what Python says in its best practices. Over here you can use a function called enumerate, which is going to do the same thing that we just did using a counter. When you put any iterable within enumerate, it generates an offset of the iterable with its position. Okay, the same thing we are able to see that once you use enumerate, it will give me a tuple with offset and the value. Okay, so we can just print this and see I'm just printing the same thing, but in case of enumerate I'm getting an offset along with the actual value. And you can unpack this enumerate value in for loop, just as we've seen how we can unpack other values. So with that you will have your counter and your actual value, that is I. So with this you can avoid creating counters in your loops and just use enumerate to figure out the offset or the count of the iteration that is going on. So the next thing that we can look at is how we can use nested for loops. It's similar to for loops only. So I'm just iterating over this string. When you're iterating over a particular string, it will take each element of the string as one iteration. So it will give me a single character at a time when you're iterating over a particular string. And in that particular string, I'm just going to print that particular element 3 times, just to give you an example of how nesting can work. So within a particular for loop, you have a nested for loops and you're printing out. So over here, let me just write the particular statement of skipping the value of y, just to recall how we can skip a particular value. Continue. Okay. Great. Now that you see, again, with this continuous statement, it is flowing the control back to the nearest loop. Okay. Now let us take one example where you want to create a list from a given list already, and you want to apply some function and create a new list from it. Okay. So say I have a list of all the integers from 0 till 10 with a increment of 4 steps, and I want to create a new list where I want to multiply each of those elements by 4 and append into the new list. So this is the traditional way of doing it. You can just create a for loop and write it this way, and it will give you the result that 0, 16 and 32 are your values. However, there is a much better and cleaner way of writing this using list comprehension in Python. So this is how you write a list comprehension. Just write what is the function that you want to apply on each of the elements of a particular list, and then you write for I in the list value or the iterable value, and outside this you just give your brackets. That could be a third bracket for list comprehension, or square or normal braces for your tuple comprehensions. And once you run this, you are able to get the same thing. You have created a new list, which is essentially the same code that we have written in this way. It is a much cleaner and Pythonic way of writing things. Great. So the next thing that we're going to look at is map function. So suppose you want to apply this multiply function to a particular element or all the elements of a list. So instead of writing a multiply by 4 or list comprehension, you can also use a map function. So map takes 2 arguments. The first argument is a function name. Mind you, it takes a function name only, not with braces or anything, and it takes a iterable. So what it does, it traverses through all the elements of the particular iterable that you have given. It could be a list or a tuple or anything, and it applies this particular function on each of those elements and gives you a new list or a new map object. Okay, so we're just going to print that and see this in action, and we are able to see that it kind of did the same thing. Now you can just change your function to multiply by 5, and it will be able to multiply all the elements by 5 and return you a new list. Okay, so with that note, this session comes to an end. Please let us know any of your feedback or comments or suggestions in the comment section below. If you have liked this particular tutorial, please share it with your friends and peers.